Welcome back to my channel, and here are 25 space facts that will blow your mind. Our moon moves about 4 centimeters farther away from Earth each year, a seemingly insignificant change with potentially catastrophic consequences. Although Earth's gravity should prevent the moon from escaping into space permanently, the increasing distance will eventually slow our planet's rotation, lengthening a day to surpass a month, and fixing our ocean tides in place. Black holes, typically born from the demise of massive stars, are incredibly dense regions of space with immense gravitational pull, capable of ensnaring light and distorting time. A small black hole in our solar system would disrupt planetary orbits and tear the sun apart. If that's not frightening enough, black holes can zoom across the galaxy at millions of miles per second, leaving destruction in their wake. Gamma ray bursts, the most potent explosions in the universe, are intense bursts of electromagnetic radiation carrying as much energy in milliseconds as our sun does in its entire lifespan. If one were to hit Earth, it could strip the ozone layer in seconds, potentially causing a mass extinction event like the one 440 million years ago. Zero gravity, scientifically known as microgravity, occurs when an object is in free fall and seems weightless. While floating like astronauts might seem fun, prolonged exposure to zero gravity can have lasting mental and physical effects on humans. On Earth, metals react with atmospheric gases to form a thin layer of oxidation. However, in the vacuum of space, where there's no atmosphere, metals don't oxidize. This leads to a phenomenon called cold welding, where two metals of the same molecular makeup fuse together permanently when pressed. While intriguing, cold welding posed challenges for early satellites and makes in-space repairs quite tricky. Considering the vastness and age of the universe, the likelihood of other planets evolving life similar to Earth is quite plausible. Fermi's paradox highlights the contradiction between the high probability of extraterrestrial life and the apparent lack of evidence supporting it. It's a tough call, really. Which scenario sends shivers down your spine more? The haunting notion that we might be the sole inhabitants of the cosmos, or the unsettling prospect that we're not? Rogue planets, those cosmic vagabonds flung into space after their planetary systems formed, drift untethered through the void, colliding with celestial bodies along their aimless journey. Despite their lack of solar allegiance, these nomadic worlds often boast chilling surface temperatures. Yet amidst the icy desolation, some daring minds speculate on the possibility of vast subterranean oceans, warmed by molten cores and insulated by icy shields, potentially teeming with life forms beyond our wildest imaginings. Back in 1969, when Neil Armstrong first set foot on the lunar surface, it took the Apollo 11 lunar module a mere 3 days to traverse the void to our nearest celestial neighbor. But since then, our technological prowess has catapulted us further and faster through the cosmic expanse. The red deserts of Mars now beckon, tantalizingly close at a mere 7 to 9 months' journey, while even the distant realms of Pluto could be reached within a decade. Yet, as we gaze further into the abyss of interstellar space, the challenges grow exponentially. Even traveling at the breakneck speed of light, our voyage to the nearest star, Alpha Centauri, would span over 4 long years, while reaching the heart of our own galaxy, the Milky Way, would test the limits of human endurance with a journey stretching over 100,000 years. Space, that vast and unfathomable expanse, presents us with extremes beyond our terrestrial comprehension. From the searing inferno of a supernova, where temperatures soar to a staggering 50 million degrees Celsius, 5 times hotter than the most powerful nuclear blast, to the bone-chilling void of cosmic oblivion, where temperatures plunge to a numbing minus 270 degrees Celsius, just a hair's breadth above absolute zero. The cosmos is a realm of extremes where survival hangs by the thinnest of threads. And then there's the darkness. Fear of the dark, that primal terror rooted deep within our evolutionary psyche, isn't just a childhood phobia. It's a survival instinct honed over millennia to protect us from the unknown dangers lurking in the shadows. Sure, as adults we may scoff at the idea of monsters under the bed, but in the vast emptiness of space, darkness isn't just an absence of light. It's an endless abyss of uncertainty stretching out into infinity, a reminder of just how small and insignificant we truly are in the grand scheme of the cosmos. Thus, feeling apprehensive about the perils lurking beyond our sight is a perfectly reasonable response. Magnetars, those incredibly dense neutron stars, compress an entire stellar mass into a sphere just 15 miles across. A teaspoon of their matter equates to the mass of 900 Great Pyramids of Giza. Yet what truly sets them apart are their magnetic fields, the mightiest in the known universe, so potent that they tear apart anything foolish enough to venture too close, atom by atom. Maintaining adequate exercise becomes an even greater challenge in the weightlessness of space. Astronauts aboard the International Space Station have shown alarming signs of muscle atrophy after just 6 weeks, despite rigorous fitness regimens. Despite its romantic name, Venus is a veritable inferno, with surface temperatures nearing 500 degrees Celsius, atmospheric pressures 90 times greater than Earth's, and a constant deluge of sulfuric acid rain. Landing there would be a death sentence. Our knowledge of the universe is staggeringly incomplete. We've only glimpsed less than 5% of its composition, with the remaining 95% comprised of enigmatic entities, dark matter, and dark energy. Dark matter, comprising a quarter of the cosmos, eludes detection but influences cosmic behavior. Dark energy, constituting the rest, remains largely mysterious, yet it undeniably drives the universe's expansion. Background radiation, a ubiquitous phenomenon in space, poses a grave threat. Cosmic rays, solar winds, and electromagnetic particles pervade the cosmos, subjecting astronauts to the equivalent of a full-body CT scan's worth of radiation every 5 to 6 days during interplanetary travel. Those who survive the journey risk developing severe radiation sickness or cancer. Hypernovae, celestial explosions with a staggering 100 times the energy of a standard supernova, mark the dramatic demise of massive stars. Though the triggers of these cataclysms remain fiercely debated, the aftermath often births black holes or neutron stars. These cosmic eruptions also birth gamma-ray bursts, visible to telescopes millions of light years away, painting the cosmos in fiery brilliance. Space, with its near-perfect vacuum, is eerily silent, a void devoid of sound. But silence doesn't mean absence. In the absence of gases to carry sound waves, electromagnetic vibrations transmit eerie whispers across the cosmic expanse. NASA's recordings of these vibrations from celestial bodies produce chilling, sci-fi horror-like effects, reminding us of the mysteries that lie beyond. In space, every action carries dire consequences. Even the slightest misstep can spell doom. Of the 430 humans sent into space, 18 never returned. While technological advancements have made space travel safer, the risk remains ever present, especially as we set our sights on destinations like Mars, where the perils multiply tenfold. Einstein's theory of special relativity unveils the strange phenomenon of time dilation. An astronaut hurtling through space at near light speeds experiences time at a different rate than a stationary observer on Earth. Though imperceptible to them, upon the astronaut's return, they find that while years may have passed on Earth, only a fraction of that time has elapsed for them, a tantalizing glimpse into the mysteries of the cosmos. Hypervelocity stars, flung into the depths of intergalactic space at speeds up to 2 million miles per hour, are cosmic vagabonds born from close encounters with black holes. These celestial speedsters streak across the void, a testament to the violent forces that shape the universe's grand tapestry. While most hypervelocity stars we've identified thus far resemble the Sun in size and mass, they possess the potential to vary widely in size and achieve even more astounding velocities. Our seemingly benevolent Sun harbors a tempestuous side, unleashing massive bursts of solar radiation known as solar flares. Though unlikely to directly harm life on Earth, these flares can induce electromagnetic pulses that wreak havoc on power grids, disrupt radio communications, and render technology useless. Space devoid of air presents dangers beyond mere breath-holding. The human body is finely tuned to Earth's atmospheric pressure, as evidenced by the ear-popping sensation experienced in high-altitude environments. In the vacuum of space, however, the absence of pressure spells instant catastrophe. Bodily fluids boil and evaporate, causing rapid expansion until the unfortunate victim bursts like an overfilled balloon. As for the universe itself, its demise looms on the horizon. While the specifics remain uncertain, scientists agree that an ultimate end is inevitable. One prevailing theory predicts a big crunch, where the universe's gravitational forces reach their zenith, causing it to collapse inward until it vanishes into nothingness. Another chilling scenario, known as the Big Rip, envisages the universe expanding to the point where gravity loses its grip, leading to the dissolution of even particles and atoms, as the cosmos unravels into oblivion. Deciding which fate is more terrifying is no easy feat. Each possibility offers its own existential dread, underscoring the profound mysteries and uncertainties that pervade our understanding of the cosmos. Enjoyed the video? Make sure to press that subscribe button so you don't miss out on my next video.